I work in a crazy place. I work at NASA's Jet Propulsion Laboratory, and just a few minutes ago, ESA, the European Space Agency, landed on a comet for the first time ever. So, a hand for our friends in Europe. Also, last night, yes, yesterday, it was 2 hackathons here, and we were part of both of them. And the winner of it was, where we had a challenge, was Hike on Mars. And it was all using Amazon services. We had 5 teams focused on JPL challenge, working from 8 a.m. till midnight. And they were going at it the whole time. It was amazing. The other one was the Internet of Things and Maker Faire. And so I think this is the key to the cloud. It's innovation everywhere. So we do a lot of spacecraft across the solar system and beyond. My present to you is download JPL Spacecraft 3D, and you can interact with it in augmented reality on any device you want. And you can learn more of it, and that's happening through the cloud capabilities on a mobile device. So this is a story of 2 sites on Mars. 2 years ago, hopefully you saw Curiosity land on Mars. We used Amazon's cloud, and we were able to save 100 to 1,000 times more cost-effective than 9 years before, and we streamed 175 terabytes in just a few hours. It was a big deal for us. Now, so there was a sky crane maneuver. This is the first selfie from another planet. Curiosity took its giant robot arm and took a selfie. So that was huge. But now here's another challenge. That was something new. How do you do it on something existing? How do you change a culture? So how could we infuse new technology into a flagship mission, quickly, inexpensively, without risk, that gets used by the users, the operators, and that has a huge and lasting impact? That's the conundrum. So what we did is we found that the cloud, all the investments we've done in the cloud, and if the JPLers and the Amazon team that's worked on JPL can stand up, I really appreciate it. If you're here this morning, because you've done an amazing job. And what we have done, and what the promise is here, is to change the culture to one of experimentation and risk-taking, but measured risk. So what we did is we used, in our case, GovCloud, because it's ITAR safe, to be able to put the data in, take a copy of the real data, and then experiment like crazy with a whole bunch of new technologies. And I'll show you in a second what they were. So then search, and now take the paradigm of how we work with our stock. Can we do that on telemetry channels? So today, or yesterday, what we did for MSL, which is the Curiosity mission, they would actually take the data, put it in PowerPoint, and then analyze the PowerPoint. Not very effective. So what we did was we built a prototype. We copied the data into GovCloud. Then we experimented with new technology. So what you're seeing here is you're seeing a telemetry channels from Curiosity, from Mars, and they're interacting with all their data in real time as opposed to a PowerPoint. So you can see them span across the data. It's about 200 million data points, all in the browser for the user. And they can look at the trends, they can smooth it, they can average it, they can do things like look for the minimum and maximums. This is thermal. If you can figure out the temperature of the rover, you can get 40% more drive time without spending any money on Mars. The other thing they can do is, before they would try to send the PowerPoint, people would have to come into JPL to analyze the data, the experts. Now what they can do, since it's all in GovCloud and the state is saved, they can take these 200 million data points, what they worked on, and they can email it to the expert, whether the expert is on the beach and log in through a VPN. And now the expert can continue the analysis. And then they can actually, because we had the pictures in the cloud already, they just click on that data point of those 200 million, and you can see what picture the rover took at that time. So you get context. Huge change. Tremendous benefit. And what we found is that the developers took it, liked it, and now they'll bring it to the next mission. So one of the executive council members said, could you do that on a spacecraft that hasn't launched yet? SMAP, soil moisture active passive. It's going to launch in January or February. And yes, we could. So we used an open development methodology now. So people were able to reuse inside JPL, we used GitHub Enterprise. And they were able to take this code, and when you see he zooms in there, and you see those dots, that's 2.4 billion data points just copied from GovCloud in real time. That's how fast it is. So the fact that it's not stored at JPL didn't matter. Now they can compare, just like you would compare different stocks, they can compare different streams, different telemetry streams, and for context and understand how one instrument affects another. All the history of the project. And because this hasn't been launched yet, once it gets launched, now we can see how it performs as it circles the Earth, looking for droughts or how to prevent droughts. This is a jumbly, googly gook thing of technology that we couldn't even spell. But because we took the data, we copied it into GovCloud, which is ITAR safe, and we were able to now take all this new technology, experiment on it, we were able to have this impact. We found that we didn't have to copy it back into the old systems because they're overused and overloaded, but we could now have an analytics cloud. And this has spread the adoption of cloud at unheard proportions. And of course, Amazon was smack in the middle of that, and those are the services we ended up using on this. So in the end, we ended up being able to have Watson experiment. We know the 1,000 ways of building a light bulb. Now we can do 1,000 ways of experimenting on missions. On the left is SMAP, and you will hear a lot about that in January. On the top is the asteroid retrieval missions. We're going to go out and grab an asteroid, put it in orbit around the moon, and to be able to analyze it so that if a big one gets close to us, we can divert it. At the right-hand side is Europa. It's a moon of Jupiter, most likely to house life, or at least signs of life. And the problem is it has a kilometer of ice thick around it. The bottom is sending humans to Mars. All of these things required very rapid prototyping, very quick analysis, infinite compute capacity, and that's what the cloud gives us. It's been an innovator accelerator, and hopefully it'll do the same for you. So thank you very much for your time.